Hey everyone, this is the new unit of statistics, and statistics is the study of collecting and analyzing data and trying to make predictions off of it. So this will go very well with your project. If you don't have this in your project, it's new, so it's fine, but it will help you with your evidence, and if you use statistics in your evidence, it will be pretty promising for your grade. Not to say that you can't get a perfect score without it, but it will definitely be easier with it. So first off, statistics. You might have learned before about populations and samples, but just in case you need a little bit of a refresher, we can take a little refresher course on it. So the number one thing we need to remember is something called a population. So a population is the entire group that you're studying. So for example, you want to study your school, which is about 300 students. Okay? Those 300 students are your population. Now, what you're studying depends on your question, whatever you want to learn. For example, what's everyone's favorite color? What's everyone's favorite subject, favorite sport, whatever. Whatever you're studying, the entire group, which in this case is your school, that's your population. So in that population of 300, it would take a very, very long time to ask all 300 students what's their favorite sport, what's their favorite color, and sometimes you don't have that kind of time. So what we'd use in statistics is something called a sample. Now, a sample is a part of the population that is randomly chosen. There are two kinds of samples that you could have. You could either have a random sample, and this is the one that you want, and I'll explain what that is in a bit, or you could have a biased sample, and that's the one you don't want. Now, a random sample means that every single person in the population has an equal chance to get picked for your sample. So random sample means every person, item, or thing in population had an equal chance to be a part of the sample. So that could be anything from, like, I don't know, asking every third person who comes in through the door. You could ask, I don't know, you could assign everybody a number and you randomly pick those numbers from a hat. Anything that has every single person in the population having an equal chance of being picked, that is a random sample. That is the sample you want. If it's not random, it's biased. Biased means that not everybody had a chance, or maybe it could even be that the population that you're choosing is not a good choice. For example, if you wanted to ask, what is your favorite sport? And you want to ask that to your school. And the way that you ask it is you want to know every 10th person who comes to the baseball game. So this is your question. The way you're sampling. You want to ask every 10th person who comes to the baseball game. In theory, every single person has a chance to be picked because it's every 10th person. You are not picking. It is a random chance. It's just whoever comes gets chosen. However, because it's at the baseball game, chances are the people who are coming to the baseball game are going to say baseball. So the question itself tells you that you probably shouldn't choose a place that has a possible answer to it. Now, what I mean by that is you're going to a baseball game, so that's going to affect people's answers. Yeah, I'm going to say baseball. Or if you went to a basketball game, people are going to say basketball, football, whatever. All these places you probably don't want to ask. Instead, maybe instead of baseball game, you could say, I don't know, the 10th person who comes to the cafeteria. Yeah? Or 10th person who comes to the musical. whatever. Something that doesn't have to do with your question. That's how you make it random. Because if the way that you're sampling affects your answers, that's going to make it biased. Now that's going to come with a little bit of practice. It's going to come with a little bit of doing it over and over again and finding the perfect kind of sampling method. But right now, the one thing you need to keep in mind is, 1, did everybody have an equal chance of getting picked? 2, is the place that I'm asking going to affect the answers? Yeah, so the 2 things you need to keep in mind is, 1, did everyone have an equal chance to get picked? 2, is the place where I'm sampling going to affect the answers? Okay, and so those are your two basic parts of statistics. You have a population and sample. Now you're going to make predictions based off those populations and samples, but that comes a little bit later. Right now, this is what you need to learn. So that was the background data that you're supposed to know, and now you're going to enter the 8th grade material, the new stuff you're supposed to know. And what you're supposed to learn here is called bivariate data. And bi means to, variate means variable. So bivariate data just means data with 2 variables. Now, before I've taught you that there's usually 2 variables. You have an x, which is your independent, and you have a y, which is your dependent. But in this case, there's not necessarily a dependent and independent variable. Okay. For example, with this kind of data, you would be given information based off a sampling. Now, that sampling could say, let's say, this is the temperature. Oops. This is the temperature, and then this is the number of ice cream cones sold. I'm just going to leave it as number of ice cream. Now, normally you would assume that that temperature, as temperature goes up, the number of ice cream also goes up. Now, this is true. There is a relationship between temperature and ice cream sales. However, you cannot say that ice cream is dependent on temperature because it's not consistent. You cannot tell me with certainty that if it is 80 degrees outside, that you will sell 5 ice cream cones. It doesn't really work that way. When you're dealing with x's and y's, it's exact. If I get 1 x, I get 3 y's. If I get 2 x's, I get 6 y's. It's always predictable. Remember, we talked about functions. It's predictable and consistent. With bivariate data, it's not always consistent. You could have the same temperature the entire week and sell different numbers of ice cream. There's a lot of different factors. What you can do, though, is figure out things like association, and we'll go over that. So I'm going to put in some data values I'm just going to put in some random data values. So let's say we have, not 30. Let's do 70, and then let's say they sold 20 ice cream cones. And then we went to 75, and then they sold 24 ice cream cones. And then the next day it was 76, and they sold 23 ice cream cones. And then say they went up to 78, and they sold, 30 ice cream cones. And then it went up to 80, and they sold 42 ice cream cones. All right? This is just random data. Now, remember we talked about sampling. This is the numbers that we got from the sampling. We chose 5 random days, got their temperatures, and then measured how many ice cream cones were sold on that day. In this case, I made it up, but in real life, you would actually go out and sample this. So now what we're going to do is we're going to graph this data. First thing to do is always remember to label your graphs, otherwise we have no idea what you're talking about. Typically, I want to put temperature here for no particular reason, and I'm going to put ICC. Oh, what is happening here? Why is this not drawing anymore? Oh. ICC for ice cream cones. Okay. And then I'm going to graph this. So let's say that this is 70. Let's say that this is 75. Let's say that this is 76. Let's say that this is 78. And let's say that this is 80. And then we have 20, 24, 23, 30, and 42. And all I'm doing is just graphing. I'm intersecting where they are. So it's kind of like a battleship. So I know that I'm supposed to hit 70 and 20 because at 70 degrees they sold 20 ice cream cones. So that's right here. And then I know that at 75 they sold 24. So let's say right here. By the way, I'm just showing these line dots so you can see where they intersect. You don't have to do this, and it's fine. 76 is 23. So moving this up. That's 23. 78 got 30. Do that in orange. So there's that. And then this one has to go there. And then I'll do this one. 80 got 42. Okay. So these are my data points right here. This is the point. These are the stuff that you really need to look at. So I'm going to do these in black. Fill with solid color. Make it black. I'm going to fill these in with black, and that's not what I wanted to do, but that's okay. So that you can really see these data points for where they are. All right. So these are my data points. I need to now find out if there's even a relationship between ice cream cones and temperature. Now I'm going to go over the 3 different kinds of associations. And an association is just a relationship between 2 things. For example, if I have a graph that looks like this, right? Oh, I wish these would come out a little bit better. Sure, good enough. Why not? So let's say it kind of looks like this, right? I can see that as this goes bigger, and this also goes bigger. Do you kind of see that? It's a positive movement. It's going up the farther you go. This is a positive association. That means that when you have more of whatever's here, you get more of whatever's here. All right, that is a positive association. Then you have the opposite of that. You have something called a negative association. And a negative association is exactly what you think it would look like. It would go down. As you can see, they're not really connected, they're not really aligned. It's just kind of a trend of decrease as you go from left to right. Now remember, as a graph, you're always reading left to right. So you can kind of see that this, if I were to draw a line, following kind of this pattern, of course it's not going to go through all of them, it's going down as a negative association. That means that as one of these goes up, the other one is going to go down. Okay? And then you have something called no association. Now, this is for 2 variables that we put together that really don't have anything to do with each other. So, for example, it's going to look like, oh, I wish this were a little bit better. It would look something like this. So as you can see, these dots, I can't really draw a line to follow a pattern. it doesn't really do anything. It seems like the points are a little bit random. That's a no association. That means that whatever this is and whatever this is, they have nothing to do with each other. So that can be something like the number of legs on a chicken and the number of eggs that it lays. It really, they don't have anything to do with each other. Okay? What we have here, though, is our points. It seems like, if I were to take my brush here, and let's say I'll use this, what would be the easiest to see? Let's use red. I did this, and I just chose red, and I drew a line to try and kind of follow this pattern like this. You can see that it's going up from left to right. That way we know that this is a positive association, okay? Now, what does this have to do with your project? Well, you have to give evidences as to why you think certain things will be sold better than others. If ever you were to find statistics or data on the internet, by the way, you're free to do that, or even if you want to create your own little makeup thing here, that's fine too. I just want to see that you can apply it. If you can show a graph like this, obviously make it look a little better than mine, but to show that it gives a positive association that, yeah, the more I sell, the higher my money goes, yeah, go for it. And if you need further explanation on this, I can do this during office hours. So this is your beginning of it. Remember, the three major things that you need to remember right now is first, your population, your sample. What is your group that you're studying? How are you doing this sampling? Second, once you get your sampling, and this is my data from my sampling, what kind of association am I going to get? Am I going to get a positive association as it's going up? Am I going to get a negative association going down? Are they even connected? Is there even an association? That's the second thing you need to remember. And the third thing you need to remember is to always label your graphs. Please label your graphs. If you don't label them, it's just a bunch of dots and nobody really knows what it's about. For example, right here, you have no idea what I'm graphing. You have no idea what I'm graphing. All you know is that there is a negative association, but you don't know what it is. So please label. And that's it for today. Have a good day, and I will see you on Tuesday.